The second area I want to talk about, and I'm especially excited to talk about it because I refactored a lot of code and added support for a lot of this stuff, is roles and permissions and role management. And so an important concept in security is confidentiality, and I hope you're all familiar with this one. Basically says that we want the stuff that should be secret to remain secret. And we want to ensure that only the people who are allowed to access our stuff can. And in Scylla, this means that we want to limit who can read certain parts of the database. And another important concept in security is non-repudiation. And the definition of this is that nobody can refute the state of data, but that's a little hard to understand, I think. What it really means is that we understand exactly how data came to be the way it is. We understand who did what, when, what they did, and how they did it. And we can be sure of that information. So the combination of defining what exists in the database in terms of describing the different things that are in there, and how we decide and define who can do what is called authorization. Who's allowed to do what? And so we define a resource as basically an identifier for something in the database, and we have a resource describing a table, for example, or a key space encompassing many tables, or even a particular role, and I'll get to what a role is in a second. And we have a certain fixed set of permissions, like create or alter or select. And what we say is that a particular CQL operation is enabled or allowed given a particular combination of a resource and permission. So for example, if I say Joe Smith needs to be able to query the events table, then I can enable that functionality by granting the select permission to the events table to Joe, or to Joe Smith. And like with users internally, this is just a table in Scylla. And we have columns for a user, a resource, and a permission set. And so checking the permissions basically means that first, before executing any query, we have to query this permissions table for the combination of the resource and the permission, and identify excuse me, let me go back a little bit. For the user and the resource, pardon me, identify which permissions have been granted for that user and that resource, and then make sure that the operation that's being executed is within that set of permissions. And so that means that every time we execute a query, we have to do the second query to check what the permissions are. And you might think that there's a lot of overhead doing that, and you'd probably be right. So we have a caching layer that caches all this stuff so you don't have to execute all these additional CQL queries. And that cache is a time-based cache. So after a certain amount of time, the cache will be evicted, and the data will be reloaded. And you can configure the time for that at the user level in the YAML file. And so this is a nice model. It works fairly well. But then you start to realize that there are difficulties in practice, and mostly operational. So if you have lots of different tables and lots of different types of data, and you have lots of users, then every time you add a new user, you're going to have to go through this hassle of adding permissions to the appropriate things for each one. And then the problem is even more annoying when you want to change permissions. You may have to repeat this change of permissions for many, many users. And this, even describing it to you now, it sounds incredibly tedious. And as we all know, when systems are hard to use and tedious, laziness usually wins. And so what people will frequently do in the face of systems that are hard to use is they'll try to subvert them. And how would you subvert a system like this? Well, you'd probably just have a user like developer with a password like Nintendo, and you give everybody the same username and password, and everybody just uses that. And the problem with that is that you're actually subverting and missing the point entirely of using users. All the benefits that we've talked about just go out the window, because now you have shared credentials, you don't have non-repudiation, you don't know who did what, you can't limit access to information. It's a big mess. So we want to avoid systems where doing the right thing is hard. We want to develop systems where doing the right thing is out of the hands of people. So a role is a concept that stems from this idea that if you have a large number of users, they're probably doing similar kinds of things. They're probably going to have access to the same kinds of data. And so what we do is we abstract this set of permissions and resources into a named entity called a role. So a role is just a collection of permissions and resources. And unlike users, we can assign a role to another role. So let me explain what that means with an example. Oop. Did I miss a slide? OK, I'm going to just go backwards after. So for example, all the analysts at our company are going to be assigned the role analyst. And all analysts need to be able to query the customers table. And Joe Smith is an analyst, so we're going to grant him the analyst role. And that means that Joe Smith inherits all the roles that have been granted, all the permissions that have been granted to the analyst role. And now let me go backwards. So you may be asking, well, what about users? And the interesting thing is that all users are roles. Roles are a generalization of users. I'd like to think that users are just roles that can log into the system. So there's a login flag when, if you allow a role to log in, I call it a user, but otherwise it's a role. And, but really, roles encompass users. Roles are the abstraction that we want to be thinking about here. So implementing roles is it required lots of implementation changes to the code and refactoring and restructuring, but that's not really what I want to talk about. The most important thing is that logically, roles and their relationship to each other form a directed graph. And you can see in this example here that I have the Joe Smith user, the Tim Jones user, and I have two roles, analyst and team lead. And I'm going to grant analyst to Jay Smith. Jay Smith is an analyst, and Tim is a team lead. But also I want the team lead to have all the permissions of analyst. And so what that means is if we think about our graph that's formed, we see that an edge from one node to another implies that that node is a member of another node. So Jay Smith is a member of analyst. So Jay Smith is an analyst. And so if we want to identify the roles of all the roles of a particular user or of a particular role, we can just follow the graph. So T. Jones is a team lead and is an analyst. So we're just following until we can't go anymore. And so what we do is we implement this directed graph representation again in a table in SQL, in CQL. And we just do that as a collect an association from node to node with edges. And what's very nice about this feature of roles is that once we actually enforce the difference between a user, who is an individual, an identity, and a function, which is like what they're doing, what they're actually doing with the database, is now we get access to a whole lot of nice security features in addition to functionality features, which Avi alluded to, and I'll mention again in a second. So one of them is auditing. And auditing is a means by which we can record who's doing what at any time to the database. We can track who's issuing queries, which tables are affected, the IP address, the date, the time. And this is a feature that's available in the Enterprise edition of Scylla. And you can produce this information and output it into Scylla internal tables or syslog. And it's very configurable, and it's very fine-grained. And if you don't employ a proper separation between users and roles, you don't get to benefit from this information because you're going to be reflecting very broad information that's not particularly useful. So this is a very, very small example from our documentation. I think the formatting is a little bit off. I'm sorry about that. But you can see that T. Jones dropped the team roster from the NBA, and I hear they're really angry about that. So, before I go on, I did want to allude to what Avi mentioned earlier in his keynote, this notion of roles as being the way that we interact with the database rather than being tied to a particular user, because a user can inherit a role, means that when we talk about features like role-based SLAs or different kinds of workflows based on particular needs, we can actually use roles to talk about this and implement this internally. So if we, for example, have an analytics workflow and a real-time workflow, then maybe we can define an analytic role and do all our analytics workflows with queries with that role. and then we can ascribe or define certain performance characteristics of that role, of queries executed by that role. And having this model allows us to manage things like different access patterns in the database in ways that we really couldn't do before when we had this broad notion of users. Because how do you deal with an analytics user? You can only have one user at a time in the database for a given in a given session. So this is very useful and important stuff that actually has performance implications as well.